Okay, guys, today we're looking at notes number 4, which is writing expressions. An algebraic expression, which you are going to become very familiar with, is an expression that contains one or more variables and may also contain operation symbols such as adding and subtracting or multiplying and dividing. A variable is just a letter or a symbol used to represent an unknown or unspecified number. I'm going to write down just at the top a couple examples of an algebraic expression. We could just have the variable x. We could also have w plus 2. Another example might be 150 plus y. Those are all different types of algebraic expressions. You may also notice that an expression does not have an equal sign. I'm going to move down to where it says writing algebraic expressions. It says in algebraic expressions, multiplication and division are usually written without the normal multiplication and division signs that you've seen in elementary school and up until this point. There are several different ways that you could potentially write a multiplication or a division problem. When you have 3 times n, and that is a variable, you're actually going to write that as 3n right next to one another. Or you could see it written as 3 dot n or n dot 3. That little dot represents multiplication. In a division problem, you're going to see 3 divided by n written as a fraction. You're going to see 3 over n. There are several different ways to describe expressions using words. What I want you to do before we get started with the examples is I would like you to go out and just Google search a few examples of words that would describe adding, subtracting, multiplying, or dividing. For example, a word that may mean to add would be plus. A word that may mean to subtract might be less than, and so on. I want you to pause your video, and after you pause your video, I want you to go out and get a few examples, maybe 2 or 3 on your own of each, and then when you are ready to go on, unpause your video, and we will compare our answers. Now that you've gone out and Google searched a few words that mean to add, subtract, multiply, or divide, I'm going to show you what I came up with. Now, your list may look a little different than mine, but if you would like to add my words to your columns as well, that might be a great idea. So words that mean to add, you may see plus, added to, some, more than. Words that mean to subtract would be less than, minus, difference, subtracted from. Multiplication, times, multiplied by, product, or groups of. And division, divided by, divided into, or quotient. These may look quite familiar to you because in our last PLP, or one of our last PLPs, you actually had to go out and do this before. So that shouldn't have been too bad. All right, let's go ahead and look down at example 1. Example 1A says write each phrase as an algebraic expression. Write each phrase as an algebraic expression. Our first bullet point says the sum of 7 and x. If I refer back up to my list of words, I know that sum means the operation is going to be addition. The algebraic expression that we may write from that is 7 plus x. That means the sum of 7 and x would be 7 plus x. Let's do the next one. the quotient of z and 3. If I refer back to my list, I know that quotient is telling me that the operation is going to be division. So I may write the algebraic expression as z over 3, or z divided by 3. Okay, guys, now we're going to actually do the opposite. B says write a phrase for each expression. So we have 11x and 8 minus y. 11x, it's asking you what operation is that? Well, if I go back and refer to the top, I know that if I have a number next to a variable, it's telling me that that's multiplication. So, once again, 11x, the operation is multiplication. I would write the phrase as, this is the product of 11 and x. Product, I use that word because that means to multiply. My second example says 8 minus y. I can tell right off the bat when I see this sign that the operation is subtraction. If I was going to write a phrase for that expression, I might say y less than 8. I could also say 8 minus y. What I'm going to have you do next is I'm going to have you go down to your turn. I want you to once again pause your video. I want you to see if you can get numbers 1 through 6 figured out on your own. Numbers 1, 2, and 3, you are writing each phrase as an algebraic expression. And numbers 4 through 6, you're going to write a phrase for each expression that's listed. So go ahead and pause your video, and once you're ready for the answers, you can unpause. Okay, now that you're ready for the answers, let's look at numbers 1, 2, and 3. It was asking you to write the phrase into an algebraic expression. So number 1 says n times 7. I wrote that as 7n. Guys, just so you know, you will never write or see the variable written first. You will always see the number and then the variable. I put them right next to each other because when I multiply, I can put the number and the variable situated right next to each other. Number 2 says 4 minus y. That one was pretty easy. All I had to do was write 4, subtraction sign, y. Number 3 says 13 added to x. Guys, you have to write x first, then plus 13, because you are adding 13 to x. That's represented as x plus 13. Please once again make note that there are no equal signs with these expressions. Okay, let's look at the second part of your turn. It says write a phrase for each expression. For 4, I saw that that was a division problem, so I wrote x divided by 12. That's going to be my phrase. For number 5, I saw a number and a letter, a variable next to each other, so I knew that was multiplication. So I chose to write that as 10 multiplied by y. You could also write 10 times y, or the product of 10 and y. And for number 6, that is c plus 3. I knew that was addition, so I wrote the sum of c and 3. You could also write c plus 3, 3 added to c, so on and so forth. The last part of our notes, we are going to model some real-world situations when it comes to writing expressions. Our example 2 has an A and a B. A says tickets to the water park cost $53 per person. Write an expression to show the total cost of tickets for a group of people. My important information that I want to maybe underline or circle, $53 per person, and I'm trying to find the total cost of tickets for a group of people. It says a group of is a clue to multiply. The ticket price of $53 is a constant. That means constant. That means stays the same. If you want to write that down, that might be smart. Constant means it stays the same. The number of people who need tickets is a variable. It's a variable because we don't know the value. We don't know how many people we're buying tickets for. Okay, it's an unknown. That's why it will be our variable. So it says, let's use X for the number of people. The algebraic expression for the total cost of tickets would be represented by 53x. X being our variable, or our number of people that would be buying a ticket, which is unknown at the moment. 53 being the cost per person. Letter B says, Jeannie has some savings. After babysitting, she adds $75 to her savings. How much money has Jeannie saved? Well, let's see here. I know that she adds $75 to her savings. And I'm trying to figure out how much money has she saved total. So let's look at this. It says adds is a clue to use addition. The $75 that Jeannie added to her savings account is a constant. There's that word again. Constant means stays the same. The amount of money Jeannie had saved before is our unknown. So we want that to be our variable. Let's use Y for Jeannie's savings before she adds the babysitting money. So the algebraic expression for Jeannie's total savings would be Y plus $75. Y being the money that she had in her savings before she added to it, and $75 being the money that she added to her savings account. What I want you to do is, knowing that information, I would now like you to do the your turn. You have one problem. When you're ready for the answer, go ahead and unpause your video. So while you're doing the your turn, pause your video and then unpause for the answer when you're ready. Okay guys, almost done. This your turn says, Helen divides up some money to give equally to her 4 nieces. I circled divides up because that's going to tell me, that's going to give me a clue as to what operation I'm using. And 4 nieces because I figured that was probably an important part of the problem. It says if D represents the total amount that Helen has, write an expression to represent how much money each niece is going to receive. Letter A says the phrase divides up is a clue for us to use division. Then what I did is I knew that D was my total amount, and I was going to have to divide that up among 4 nieces. So my expression that I wrote was D over 4. The total amount, which is unknown at the moment, which is why I used a variable, divided by her 4 nieces.